All right. This next speaker, I was talking with Courtney Kistler at the DevOps Enterprise Summit a couple weeks ago, and I mentioned that the speaker was going to be coming to Chattanooga's DevOps Days, and she was really excited. This person has been a thought leader and is really making moves. And Jennifer challenged me to come up with a completely different introduction for her when she came up here, because she's coming up here again. Jennifer Davis, thanks again, and thanks for coming at such short notice.
Okay, hi everybody. Okay, so I'm an afternoon person as well. So as I mentioned earlier, I have about 21 years of experience now in industry, and I have done everything from working in academia to small startups to large enterprises. I've been an operations engineer, I've done consulting, I've worked in open space, now I'm an advocate. My role is to help make things better for operations engineers. That's my focus. I'm actually not a developer advocate, I'm an operations advocate. Because I don't think developers are the most important people. I think everyone has an important role. And one of the things that I wanted to share is that, yes, I've co-wrote this book, Effective DevOps. It's a great starter place to understand some of the important concepts. I'm working on this modern system administration book now because I want to distill those technical patterns and tools that are helpful for everyone. But I want to encourage you, if there's parts of your job or parts of what you've learned today that you found valuable, share those stories with me. I'm planning on including stories in this book. So that's my last little plug for that. So today I want to talk about something that is a little bit intangible. When I think about what it is that what we're building, often I hear people talk about, well, security is something that you contemplate against features. Like I choose features or I choose security. And then it turns into this money discussion, and security just costs money. I think that we need to talk about trust, which is intangible, and yet it's so critical. It is the building blocks of how we build effective products, work together as a team, believe in the organization's goals and values, and what our customers give to us. You can't buy trust. I can't go out there and buy it. And as soon as I release personally identifying information or have fraudulent activity on someone's credit card, they're gonna come to me and my product, and I've lost that trust with them. It's immensely difficult to rebuild trust once you violate it. Often, when we're thinking about how we build a product, we're thinking about it not from the point of view when the hackers show up, but we're making choices based on how easy the framework is to use, or what the code looks like and how easy it is to understand. And yet, security concerns are all around us. If you check out this haveibeenpwned.com site, you too can see how much of your information and what type of information has been disclosed to nefarious attackers. The complexity is these different companies are collecting different data, and you will all of a sudden find yourself thinking of all the paranoid ways that that data can become aggregate and used in conjunction, even with these different companies collecting different information. We have very sophisticated attacks at this point. But I get it. We are all human. We have a tendency to put the things that we can see and see progress on at the forefront. I mean, we haven't tackled climate change yet, and it's already having impacts with fires in California that have been exacerbated by businesses who aren't paying for their aging infrastructure. And just all of the businesses that aren't thinking about the impact of the environment based on their use. And it's not that we don't have other things to think about. There's plenty of work to do. So it's like, how do we figure out what we need to do? Security incidents are not a matter of if, they're a matter of when. So it's not that you get to all of a sudden become secure. You can't buy it from some company and say, look, I'm secure now. You are going to have an event. So how do we leverage what we have learned from different parts of the industry in working together better? Well, instead of trying to tackle this as one big item of like, let's do security, let's actually break it down into smaller pieces. And it's actually pretty interesting to me seeing the earlier DevSecOps talk. I'm talking about DevSecOps and continuous security in this talk, and yet our content is very different. So continuous security to me is applying the practices and leveraging at every point of the life cycle security principles and practices. So starting at discovery, going to development, how we build, how we release, how we deploy, and how we monitor security at every step of the way. To do this, we can't just say, hey, security engineer, you are now responsible. How many people are responsible for security right now at their company? Right. By the end of this talk, I hope that you all are raising your hand, because the lone security engineer is not a thing anymore. Yet that does not mean that we don't have security engineers. Specialization is important. It means that we all play a part in securing our applications and operations of our software. So I'm going to cover a lot of material today. I'm going to start out with establishing a common context, and then we're going to work on some of the foundations of security principles, and then I'll talk a little bit about advanced principles. It in no way, shape, or form is the whole security, this is how you're going to secure your environment. There is no checklist, there's no path, there's no, like I said, if someone's selling you, here's your free security, that doesn't exist. It is something that'll help you assess and build up your skills so that by the end of this, you have at least some idea of where you might level up your own opportunities. So BIT is going to help us set up that common context. The first thing I want to talk about is the CIA triad. And the CIA triad is sort of the security principle standard of confidentiality, availability, and integrity. If we talk about SRE, a lot of what SRE is talking about is availability. So we already see in operations engineering land overlap with security land. Confidentiality is that only the people who should have access to the data have access to it. So nobody needs to see my private, health data concerns, except for my doctor and me. And of course, if Google buys out the insurance company, true story, they shouldn't have access, but that's a different issue. Integrity is the people that should be able to modify the information are limited to just the people who can modify the information. And then availability is that you have access to this when you need it. So a lot of times people joke about, oh, it's secure if you put it in a locked room with no cables and it's off the internet and there's no Wi-Fi or Bluetooth or anything like that. But that's not really secure because no one has access. So this is one set of principles. There's a newer sort of model that people have been thinking about. And Sunil has said this is a replacement for CIA. I don't think that's quite right, but I do think this is a useful model because it addresses a lot of concerns. And the thing about it is, not all systems can be the DIE model. And so DIE stands for distributed, immutable, and ephemeral. And so with distributed, that means we can address distributed attacks because our system is distributed. It's not in one place. Immutable means that it can't change. We can quickly deploy it again if it does change. So we just need to be able to detect and repair issues if we have something that's modifiable. And then ephemeral is this idea that we can create systems that spin up very easily, and if we detect changes, we can just knock them out. And so attackers generally, they don't like to waste their time. And if the idea is that if I log into a box, it's gonna immediately get destroyed, the value in trying to install a rootkit, access a bunch of stuff on that system is kind of nullified because the system is not gonna live for very long. So, the DIE model. We have to think about, as we think about all these pipelines of where we think of our code going from one part of the development lifecycle to the next, that we have to think about how we address security concerns. A lot of times, it's an ad hoc addition. It's like, how do we repair an artifact that's been compromised? We don't think about, well, this could actually be addressed if we consider the process at the beginning and add it so it's not an exception to the rule. Security fixes follow the same path as regular fixes. Okay. So that's a little bit of security stuff, but why do we care? So understanding our attacker, who our attackers are, what data they're trying to get access to, and what motivates them, helps us to think about what we actually need to be worried about. So there was a Verizon report that kind of broke down sort of they do this every year. It breaks down the number of types of motivations, the number of attacks associated with the motivations. And one of the things that really frustrates me is a lot of people focus on insider threat. It's always about like, how difficult can we make ops' job? And it frustrates me because generally that's like the bottom of the stack. Yes, we should protect from things coming from inside the house, but the top layer of defense we need to think about is who's gonna get financial gain from the data that we're generating? How easy is it for them to access that? Because that's the #1 vulnerability. Depending on the industry that you're in, you're creating different types of data. So you may be creating, maybe you're storing credit card information, and maybe you have specific compliance rules that you need to follow through with, or maybe you're storing personal identifying information like health data. It's always, regardless of what type of data, it might change how you're attacked, but it all impacts the trust that your consumers or your users have on your systems. So in some cases, and in some areas, there might be laws that mean you have to pay large fines or even go to jail. So when it comes down to it, if you're having pushback of like, hey, I went to this talk, Jennifer says we should all be doing security, I really like this idea of doing security, it's my passion, and you get pushback, you can say, well, you know what, I heard there might be fines and jail time if we don't fix this. And that can give you a little leverage to get leadership to listen. So, talked a little basics. Let's talk about the foundations. It's impossible to release a perfectly secure application or service. So we're not trying to get 100% security. There's no such thing. Instead, if we think about layering our defense and thinking about the different areas, the endpoints that we need to protect, where our data is stored, what kind of data we're storing, we can think about being strong. So some people think of it as like the Swiss cheese effect. I like to think of like architecture because lots of this long-standing architecture has been around a very long time. And if we think like that, even if we want ephemeral systems, it's cool. These are strong, well-built fortresses, and they don't think of just one layer of defense. Another important concept to understand is least privilege. Now, this is one layer of defense, is not providing, or to define it in what it is, it's providing the least amount of access that you need to get your job done. So instead of having a root account or administrator accounts that people work with, having just specific service accounts for service systems and particular permissions enabled only when you need them. Starting with the design phase, plan with a security perspective. This means inviting people in who have that security experience and can ask the right questions. Incorporate that CIA triad into addressing issues. When you think about, okay, here I'm addressing a particular security aspect, tag it. So then when you're going back through your system, you can say, yeah, we thought about it and we did this intentionally, right? So say I have a sample application that is a web application that a user logs in, and a lot of times people will think of this in sort of the given this, then I'll do this. And from a security perspective, adding a few questions where we think about what can a user see and what can they do, what information is logged, where is it logged, how do we save that information, do we delete it at some point? And how do we approach failed logins? If someone comes in, is using our site, and they fail to log in a number of times and they're not using a password manager, it could be really frustrating if we immediately lock them out. But we could also have someone trying to get into our system, and if we allow any number of logins, that can be a problem. OWASP provides a resource, the Application Security Verification Standard Project, that has a whole set of questions to help you in your design process to think about what questions do I need to ask, and that's specifically for web applications. Another activity to do in that design phase is to think about the threats. So I talked about a little bit about what are the motivations. Well, that should include thinking about who's going to try and attack us? What are they going to do? How are they going to take that information? How vulnerable are we? There's a couple of different applications. Microsoft released a threat modeling service, as well as OWASP has one as well. Just a side note, I do have a whole list of resources that I've aggregated and posted on Twitter that has all of these links, as well as links to the slide. So depending on your platform, there's a number of trade-offs that you can make. So earlier I talked about DI. That's great. Containers are awesome. Ephemeral storage, you can bring stuff up, take it down. Sometimes we don't have that choice, and there's other choices as well. So for example, you can deploy a managed database service on Azure with all the bells and whistles, and all kinds of stuff comes for free. You get encryption at rest, encryption over the network, all kinds of compliance pieces, but you could also deploy MySQL yourself, and you could lock it all down, set up the encryption, do all of this stuff. And sometimes people go, I don't want to be locked in, so I'm not going to leverage the cloud native option. And that's not actually a valid thing to me. Like, use what you want, and if you have the skills to do the security aspect of it, sure, that's awesome. The key thing to think about is it's a choice of, do I have increased complexity of using something like serverless where there's not enough visibility, or do I want to reduce the operational burden? Because there's more operational burden as I work on-prem or use infrastructure as a service and build out my own MySQL instance. As with earlier, it's a little bit of a different visualization. We have a shared security model when we're using cloud services. No matter what choice you use, if you go all the way up to serverless, there's 3 components that you are relied on for providing the security of your systems. So while some of the different options eliminate some of the infrastructure you have so you don't have to worry about patching, you still have to think about what data are you generating? No one can tell you that except you. Like a cloud provider, they can provide encryption at rest, but they don't know what data you're creating. They know about it, but the meta about that and who should have access, which is something you would configure, that is on you. So thinking through those processes and what they look like and who should have access and when, that matters. And I don't feel like we talk about that enough. Another aspect that you have to think about is what your endpoints look like and who should have access to those and when. You should test everything. And by that, there's all kinds of layers to that. It can be super complex, but it can start out with static code analysis. One of the things that I found interesting to think about is the idea of not just testing your code, but say you have an API key and you're rotating it. Test that the old key doesn't work. Say you have data that you've deleted. Test to make sure that it really got deleted. Some people think of static code analysis as like, that's just style guidelines, that's bike shedding, who cares? Linting actually catches flaws in logic as well. So in this example, you can see the two go-to fails. I can't really point it out, hopefully it's big enough there. Basically, this was an iOS bug that because someone didn't lint, it wasn't caught, it went into production, and this allowed certificate verification incorrectly. So it basically didn't really do a verification. So linting is good. So you might say, Jennifer, that's great, but my team is not gonna do it because we just get a bunch of error messages out. And no one has time to deal with all that. Most linters you can configure and set, and you can run even a command. This is a Ruby example. You can run a command that will generate an ignore all file. And then that file, you can then slowly take and uncomment out piece by piece what you actually care about, and then let it go. So then you're tackling it piece by piece rather than trying to fix everything. That whole big project, big problems, break down into small pieces, repeating pattern. Think about the code reviews, not just having developers involved, but get operability reviews, add a security perspective. Think about what things are we addressing that are CIA and tag them. As was earlier mentioned, open source isn't by default secure. Just because it's visible doesn't magically make it secure. So many developers don't actually know how to make their code more secure, and they need a little operability and security engineering love. So if you're looking to contribute to open source, that would be awesome. But you can't create a secure application or service. You're gonna have an event. And so plan for one. There was that great talk about incident reviews earlier, or incident management. All of those are great topics from James. But think about how you identify, assess, and remediate. My coworker Jason has this minimum viable response plan resource, and I totally recommend looking at that. But security incidents are different. And I would love for us to have more talks about how we manage security incidents. Sometimes you have a long impact and you have no idea that there was a problem. So how do you recover? What if your backups have already rotated and you don't have a clean state? Sometimes there's zero impact and you need to do this now. You need to fix it now. But people want to work on features because it's not a problem right now. Well, if we change the conversation and not just talk about features build money, and we talk about security builds trust, maybe we can better prioritize what needs to be worked on. Think about your platform specificity. So again, I don't think vendor lock-in is that important. You want to leverage the features available to you at the right price point. And you want to know the specific limitations. Some of those might be your understanding of like DNS. We ran into a problem at my past job where all of a sudden there was a cap on DNS queries with a change in an instance type. And that was problematic because we didn't realize those limitations. Because cloud platforms are constantly changing, if you look at the release notes that are just evolving out there, it's like these limits constantly change. If you have knowledge built up from 5 years ago, you're constantly needing to update that, so you need to revisit. When I first started at Microsoft, I had no experience with Azure. And one of the coolest things, I'm just giving this as an example of what I mean by leverage your platform, is this Azure Security Center. And there's a free option. And many of my coworkers were like, no, there's nothing for, like, what are you talking about? And this is actually from our subscription, where I was like, hey, check this out, vulnerabilities, look, people hacking in. And what was nice is really just obvious, a score. When you click on various pieces, it'll tell you exactly what you need to fix. And in the playbook, it actually tells you, here is the steps that you need to take. Some of it's just click on this button to apply this problem fix. And so it was really interesting to me that we could leverage this, and yet so many people hadn't known that it even existed. So from discovery through to deployment and monitoring, we have things we can employ for security. Let's talk a little bit about some of these advanced topics that I mentioned. So first, there's bug bounty programs. Once you have sort of your basics supplied, you're doing some security, you can invest in some other company to come and check out your system and validate whether you've got a problem or not. You basically pay someone, you pay the company, and they create a bounty for you. And you say, here are the areas which I want to have tested. Because you don't want like your Salesforce instance to be checked, for example, or third-party services. And then there's these research scientists that are paid to find these bugs. There's also capture the flag events. These help people with their like personal security knowledge. They're kind of fun. They will also scare the crap out of you, because you'll see how easy it is to mess stuff up. But that's good, because you can see how easy it is to mess stuff up. There's a CTF with Google, and if you are a non-binary person or a woman, we also have this CTF Circle Slack. I encourage folks to join. Earlier I said it's a matter of when, not if. Red team exercises are an excellent tool in your tool belt once you have an established incident response program. If you don't know how to handle events, and that's just regular events, not just security, you do a red team exercise, especially on an unassuming team who's already stressed out, you're just going to add to their burden, so don't do that. Get your incident response working, then you can do red team exercises. So what do you do next? You identify your security maturity. You assess which of these practices are valuable to you. Earlier, I had that dungeon map from my talk from the keynote, right? No one can tell you what you should do next. You have to think about all these different practices and determine where you are and what works for you next. Encourage everyone to learn a little bit about security. You don't have to be the security engineer, but you might find that you are interested in app security or info security. It's an awesome field that's really critical. Incorporate feedback. The continuous learning cycle of learning what works and what doesn't also matters for security. Update your threat models. You're going to learn about who's actually wanting to attack you and get data from you. When it comes down to it, security is everybody's job. Who would say that they are part of their company's security at this point? Let's all raise our hands. Thank you so much. Please do continue to participate in your DevOps community, and I appreciate your feedback. Resources are available, and the slides were processing the last time I looked, so if they're still processing, I will upload them again. I appreciate it.